Ya. Start now ya. Bisa Mas ya?
Video tidak tersedia, video ini dibaca di Facebook itu.
Sudah mulai sekarang ya, shall we know? Masih banyak belum unmute ya. We will be waiting for about 5 minutes, Professor.
All right. All right.
We're waiting for some participant to join.
All right.
Di YouTube. Shall we start now?
Yep.
Oke, Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen.
Morning, people.
We would like to thank you for joining us on the open lecture series on architecture design and building science, either on Zoom or YouTube. We are pleased that quite a number of participants has registered to join this talk, not only across Indonesia, but also from Singapore, Malaysia, and other surrounding countries. Okay, I may say that this event is another token of long-term collaboration between Department of Architecture, Universitas Muhammadiyah Surakarta, and Faculty of Built Environment and Surveying, University Teknologi Malaysia. Okay, of course, we need to appreciate to our presenters today, Dr. Ling Pao Chong, Dr. Amal Tarauf Abdullah, and Professor Ismail Said. Before we begin, it seems that we need to agree with some term of condition in order to ensure the event running well, as we have also mentioned on the confirmation letter yesterday. Okay. First, participant can follow the discussion on Zoom and YouTube live on channel Laboratorium Arsitektur UMS. When you join Zoom, kindly use your real name as written on the registration form in order to check with the attendance list. All participant voice should be mute during the event unless the moderator gives the participants permission to speak over microphone. Okay, all participants can ask question by raising hand on Zoom or writing on the chat column. The question will be responded depending on the time available or will be chosen from chat line. Okay. The event then will be closed with a photo session. Please kindly turn on your camera on the end of the session. A certificate will be sent to participants soonest after the event. Okay, now I would like to greet the presenters and discussion. Welcome Professor Ismail Said,
Yeah, thank you.
Dr. Leng Pao Chang,
Okay, thank you. Morning.
and Dr. Amal Tarauf Abdullah.
Thank you.
It's so great to have you all here.
Thank you so much.
Thank you so much.
Before we start the presentation, I would like to introduce Professor Ismail Said from Faculty of Built Environment and Surveying, University Technology Malaysia, who joined us particularly to discuss the content of the presentation. Professor Ismail Said, he has been teaching for more than 35 years and much active sharing his knowledge with universities in Indonesia. To date, he has produced 30 PhD graduates and still supervising 17 PhD candidates. His research interest ranges from children's environment to urban design and planning to heritage architecture. Professor Ismail Said has published more than 130 papers in journals and 5 books. As a scholar, he has visited more than 55 universities to gain and share knowledge. Now, let's start with the first presenter. I would like to introduce you to Dr. Leng Pao Chang. He has a nickname, Dr. PC, right?
Yeah.
Okay.
Just call me PC. Yeah, thanks.
Okay. Dr. PC received his PhD in architecture from the University Technology Malaysia, UTM. He is currently a senior lecturer for the architecture program at the Faculty of Built Environment and Surveying, UTM. He is also the committee member of Malaysia Green Building Council, Southern Chapter, and seconded the position of Architecture Computer Laboratory UTM and CAD, Center of Faculty of Built Environment and Surveying UTM. Also, he is Registered Professional Technologist, PTECH, under Malaysia Board of Technologies MBOT, graduate member of Board of Architects Malaysia, LAM, and Malaysian Institute of Architects, PAM. He is also conducting teaching and learning activities for some subject courses to undergraduate students, as well as supervising Master of Architecture students in both mainstream and offshore programs. Okay, now let's have Dr. PC, who will be presenting for about 30 minutes the first topic today on architectural daylighting strategies and performance in tropical climate. Please welcome Dr. PC to give the presentation.
Thank you very much, Ibu Yai. Okay, for today's. First of all, I would like to thank UMS for inviting me and Prof. Ismail Said for inviting me to the input session. Okay, so as today's I'm going to present the topics on the architectural daylighting strategies and performance in tropical climate. Okay, because currently I'm the coordinator for second year studio, which this semester is also their semester in studying about the environmental study. So our students are going to, they are going to focus the design, the architectural design, mostly on the environmental, especially in daylighting. Since they are undergraduate students, and we think that daylighting study is considered the low-hanging fruit, which is also the one of the starting fundamental for them to understand before they start and going towards like ventilation, which is more complicated and so forth. All right, so daylighting probably will be one of the fundamental and easier for them to understand and to apply in the design itself. Okay, so Puan Yai, do you mind if I share my slide, because now I'm being disabled to share the screen.
Oh, okay.
Because I cannot share the screen now. Yeah.
Okay, from here. Okay.
Yeah. Okay. Because I still being disabled.
Oh, okay.
Or
We
to
try
share the
from
screen.
here.
Okay, sure. Thank. Okay, all
Dr.
right.
PC, maybe you can try. Okay.
Yeah, okay. I hope you can see my screen now. Now I'm in the PowerPoint mode. Okay. All right. Okay. So today I'm going to share, since I only have 30 minutes, because before that I thought it's around 1 hour. So I'm preparing around 79 slides. So, but I will try to do my best to complete, as soon as possible. But most of that will be at the ending part will be the sharing or some of the examples that I share with my students throughout the semester, because I want to familiarize themselves with the shading device and some of the daylighting features that they can apply, which is case studies that will be at the ends of the slide. So the front part will be more towards the theory. So I guess most of you maybe have already came across with that. So maybe we can just like doing a refresh studies about the theories. Okay. So without further ado, I think I start my presentation, sharing session. Okay. So when we talk about the daylighting, so everybody in architecture, the first thing that we came across the mind is like windows, because we know that daylighting is very important. So because why we need windows? Because windows can provide us with the daylighting, and in the same time provide us with the ventilation as well. Okay, so the first thing that as an architect we should design basically window, because the daylight, it can improve the energy efficiency by minimizing the use of electricity for lighting, as well as reducing associated heating and cooling loads. Okay, since I think most of us have come across with like the green rating tools, okay, which is very famous nowadays, and it's very important in the building design nowadays, especially the passive design. Okay, can you hear me?
Can you make it full screen?
Oh, okay, sure. Slide. Okay, can you see that now? Okay.
Yeah.
Can you see the full screen?
Not
okay.
Yet. Okay, yeah.
Okay, yeah. If it is clear, I think allow me to continue. Okay, so if anything, you can just inform me about it. Okay. Okay. In terms of the daylighting, in terms of the green features that we have came across, for example, rainwater harvesting, we have the green features, we have the solar panels and so forth. But before we go to the gadget, so what is most important in architecture features basically is a passive design. So passive design is like, for example, our envelope, building envelope, our roof, and so forth. So all these are quite the fundamentals as a designers, as an architect, that we should look into. Okay, so daylighting is a critical design factor to concern about the global warming, carbon emissions, sustainable design, in addition to visual comfort and so forth. As an occupant, as a humans that we occupying the buildings, we as a designer, we should make the occupants feel comfortable in terms of the thermal comfort, in terms of the visual comfort, and so forth. Okay, so research have found that the daylight to important factor influencing the human behavior, health, and productivity. If the building which is not comfortable for us, so the productivity will be lower, and it will cause the sickness. For example, the building syndrome is one of the sickness that we have always came across. We heard of. That's why, as a good designer, we should try to develop or design a good building that could provide these trees for our occupants. Windows emitting daylight provide occupants with a view and temporal connections with the outdoors. Okay, like for example, hospital. Some of the hospital design is encouraging the huge window that could overlooking the outdoor. Why? Because the view itself basically giving the psychological impact to the patients that are staying in the hospital. If imagine if the hospital is being walled up with a very small window because lacking of this daylighting, the sunlight, the view, interaction with the outdoor environment. So immediately it will cause some psychological impact, and immediately it will cause the sickness, the health problem to the occupants itself, just like the prison. So some prisoners staying in the prison because due to the environment, so some of them having the problems in psychological problems after a long term prison in the jail. Okay, so that's the importance of the building design in terms of the envelopes. Okay, so the useful daylight. Okay, Dr. John Medrijevic saying that the recommended useful daylight is around 100 lux to 2000 lux itself, but direct sunlight from the outdoor environment is more than 100,000. So it is like around 1/1000, okay, of the useful daylight that we need. That's why comparable to the outdoor environment, so we as an architect, we have to know that what is the functions of the buildings that we are trying to design. For example, maybe schools, maybe workshop itself, do we need more daylight or do we need less daylight? Like for example, we designing an exhibition hall that no need a lot of daylighting, but more towards artificial lighting. So all this is part of the tips that the things that we have to consider about, okay, when we trying to come across this. So some of the bylaws or like standards, for example, we have MS 1525 Malaysian standards have recommended certain lux that is suitable for like for example classrooms and maybe offices and so forth. Okay, so that's why the unit measurable units is important in this case. Okay, so why we choose daylight? Because it is cool and free. Okay, according to the luminous efficacies chart that you can see here, we have the incandescent light, okay, which is around 15 watt only, lumens per watts only. But compared to cool daylight, it's around 200s. Okay, so out of this one, we can see is that it's free. Then most of the time, and it's cool and free means that it's like we don't need to spend any money. Just that we have to have our own good strategies that could provide the suitable amounts of the daylighting to the building itself. Then we can save a lot of energies by means, okay, especially like offices and classroom itself that we use daily. Okay, so next one will be the benefits of the daylight. Okay, why we need daylighting? Okay, because it will give proper and better sleep for the occupants, and it will lower the blood pressure, obesity, diabetes, and all these are the problems of most of the peoples, okay, in the city, living in the city nowadays, especially because of their work pressure and so forth. That's why it will cause the problems, the health problem to us. So in the same time, it could improve the mental and function and memories. So the core processing as well as the student achievement could be improved 5 to 14% higher. So in their test score, and workers will be 18% more productive compared to the enclosed in a very dark room or air conditioned room. Okay, the buildings that don't have a proper windows and so forth. So all this could lead to some of the improvement. If we designing as an architect, we can design a good envelopes of the buildings that it can induce daylighting to our environment. Okay, so all these are based on the LEED certified buildings and some research that have been found around the world. Okay, So daylighting performance in the tropical climates. Okay, so basically, when we talk about the daylighting, there are two angles of the daylight beams. Okay, solar azimuth angles and solar attitude angles. So it's like one at the y-axis, which is the attitude, and the x-axis will be the azimuth. So two of these, for example, the azimuth will is basically the angle between the true north and the direction of the sun measured clockwise from the true north. And the azimuth determine the direction in which the shadow will fall on the ground. So if you want to know where is the locations of the shadow, so basically the solar azimuth angles is important. So the other one will be the length of the shadow cast by the solid object. Okay, so this one will be determined by the solar attitude angles, which is at the y-axis. All right. So okay. So for the direct radiation, the radiations coming straight from the sun after intentionation out through the atmosphere. Okay, so this is the direct radiation, the direct sunlight that we we're trying to avoid. For the diffuse radiation, which is like reflected light, so basically this one will be we can get this kind of the diffuse radiation through the reflection from the surface of the building, from the ground, and so forth. Okay, other than the direct radiation. So there are some tips to remember. So the daylight in the building is composed of a mix. In the building itself, we are going to get different light. One is direct sunlight. So usually this one will cause glare to us. Diffuse skylight and light reflected from the ground, from the surrounding elements. Okay. So from the suns is intense and direction. So this one we know. That's why usually we use shading device, we use curtain. The light from the sky is soft and diffuse, means that you can see the light, like for example at night time, you still can see the environment, but that is not from the sun. So that is called diffuse lighting. For the reflected light, which means that the sun directed from the the light directed from the sun that reflected from the ground is oftenly account for 15% or more of the total daylight reaching the building facade itself. So the reflected light basically is also one of the light that we came across every day, and we use in our daily life. Maybe it's not using for like writing or the proper function, but it's like for walking. At least we can see some of the light around us. Okay. So for the daylight calculation and measurement, there are basically three main measurement units. When we trying to approach the daylighting studies. Okay, one is so-called the daylight factors, which is the ratio in between the external and the internal lux. Okay, we want to see how much is the percentage, the differences. So the other one will be the illuminance and luminance. Okay, so later on we'll talk about the differences between these two. So one is directed. Okay, focusings from the light sources. The other one is reflected. So for illuminance, it's a measure of the amount of light received on a surface. Okay, usually, like in our standards, we will talk about how many lux that we receive on a surface. Like for example, when you're reading, so the amount of light that we receive is how much of the lux that is suitable. Okay, if too high, we can't see, or it will cause discomfort to us. If too low, it will cause some. It's difficult for us to read on the text and so forth if we are in the classroom. So this is the measure of light currently used by the most performance indicators to determine the daylight availability in the interiors. So illuminance is a measurement of the amount of light received by the surface and is typically expressed in lux, and its illuminance level can be measured with a lux meter. As you can see, there is a tools, the instruments over here is one of the tools that we can use to measure and can bring into your classroom, your room offices to see what is the lux amount of lux that received by the surface, building surface. Okay, and as you can see here, the direct sunlight is around 100,000 lux, which is very, very high and is discomfort. diffuse skylight is around 3,000 to 18,000 lux. But for the minimum level for the tasks and activities, for example, residential rooms, which is considered comfortable, is 200 to 500. Classroom, 300 to 500. Workspace is around 200 to 500. Because we are using computers, we're reading books, we're writing. So 300 to 500. 500 is considered the maximum that recommended by most of the standards. So luminance is the measure of amount of light reflected or emitted from the surface. Okay, so it's usually expressed in centimeter per meter square. And luminance level can be measured with a luminance meter. All right. So what is the differences? Luminance, usually we said that it's like what materials. Usually we will consider about the materials of the surface, for example, from the flooring, for the chart or the pans that we use on the surface of the wall and ceiling itself. So it will with giving the impact to the luminance itself. And the other one, what is the quite critical for us when we're trying to see what is the luminance for the room is through using the glare. Okay, if there are too much glare, means that the luminance is high, meaning it will cause more glare to the environment as well. Okay, so this diagram will clearly show you about the differences between illuminance and the luminance. Okay, and the luminous flux and so forth. Okay, so for daylight factor, how much daylight fall on the surface on the building. Okay, this is just now we did mention. So if we compare two, one is from the sky, the other one is from the daylight that reflects on our interior building itself, then we can get the percentage of the daylight factors. So it will be the ratios of illuminance measured at the same point within a building to the external illuminance, where the exterior illuminance is measured for an obstructed view of the overcast sky. Okay, so usually for the daylight factor, it can be quickly employed to a size window. Okay, during schematic designing, evaluating design suggested by the end of schematic design, or fine-tune the building proposal towards the design development. Usually when we're trying to do the simulation for the daylight factor, we will trying to use the plan views that's why we can see the overall percentage of the daylight factors. And this one will be one of the pictures showing that the average daylight factors that we can get from the simulation itself. Okay, so how much surface being illuminated by the incident light is measured by the illuminance itself. So lux. So this one is quite, you can always see that when the researchers who are doing the daylighting study, so this one will be the diagrams that they usually show in the papers. So representations of daylight factor in building drawings. So usually we'll have there are two kinds, because we call that as a isolux diagram at the left, okay, daylight factor profile at the right side. Okay, so if you want to show that how much of the differences of the daylight factor, so these tools could give you some ideas. So the colorful lines basically showing that the zones occupying, the zones are of the percentage. So red color usually will be higher. Okay, green color or the blue color will be lower lux, like for example 0%, okay, and so forth. Okay, the differences. So daylight factor profile showing you like illustrations of the real life of the environment. So it's like a rendering pictures that we usually use in architectural rendering. So from here, if you can see the black and white and gray colors like daylight factor profile, we know that how much that environments, the indoor environment would provide. Okay, if that's too dark, we can immediately knowing that that is not suitable by looking at the daylight factor profile. So for the daylight design strategies, so they are basically we have 7 kind of the different strategies in general. The first one will be the different region. From different region around the world, we have tropic climate, we have subtropics, and we have temperate and so forth. So that one will give us the different design strategies. So means that different idea, different environment or different region of around the world, we will have a different kind of the proposal in terms of the window. So for our site design, is also one of the very important kind of the exercise as an architect. Once you get the floor plan, site plan, this is what we're trying to see. And orientations, the majority of the glazing, north, south, with secondary glazing, minimizing the east-west window if necessary. So these are some of the tips that usually we came across, that we always tell the students, this is what you have to bear in mind before you start the building design. Number 4, building plan form. What kind of the form that will give more daylighting? So this one is also playing a very important role when we're trying to design. Why this is important? Because as an architect, if designing a wrong building or the building with not appropriately addressed form or positionings of the window itself, it will cause a long run cost. For example, if that's too hot, so means that if the architect designing a lot of windows at the west side, means that it will cause a lot of glare and the heat itself to the building. So in long run, the occupants have no choice. They have to install the aircon. Means that in long run, maybe 30 years, 50 years, they have to use aircon. And it will increase the carbon footprint to the environment, which is not environmental friendly at all. So architect actual fact is playing a very important role in this case. So number 5, illuminate the ceiling as much as possible because of the diffuse lighting or reflected lighting. Because the light from the sky, from the sun will be reflected from the ground, eventually is penetrated through into the indoor environment, and it will reflected through the ceiling to us on the table. That's why if we choosing the right colors for the ceiling, so it will giving the right lux, the daylighting performance for the building. Number 6, protect against the direct sunlight. This is what we're trying to avoid. Because as what I mentioned in the previous slide, so the direct sunlight basically is 1,100, is like 100,000 more, 1,000 times more than what we need. So this is not something pleasure for us that we're trying to avoid. So this one, in this case, shading device is very important. So number 7, balance light from the window wall with reflected daylight on the opposite wall. Like for example, side lighting, top lighting. So we have an atrium, courtyard, and so forth. So all of these will actually fact giving the solutions or alternative for us. For which one of the solutions is best for certain functions of the building. So for daylighting consideration in different region, as you can see here, at the left side is about the daylighting in the tropical region. So usually, what is the problem here? Usually it's like we have abundance of sunlight or daylighting. So we have to use shading to prevent the transmissions of the direct sunbeam. And we have to preventing brightness from exterior surface that reflect sunlight. Because it's too much outside. That's why penghadang, or we have to use the shading is very critical here. So in the same time, like what you can see here in the design strategies in a traditional Malay houses or even in the Indonesian houses, usually we're trying to go for the huge overhang that could, provide the shades, because shades is very important. If we receiving too much of the sunlight, it will cause glare, will cause heat to us as well, which is not pleasure. We're trying to avoid that. What we want is basically the diffuse lighting from the lighting in the arid region, hot and dry. because the environment is too much. So usually they're trying to minimize it as well, which is not high levels we're trying to avoid that. What we want is open at the courtyard, which is facing internally. Because if they're facing outwards, so there were too many sands or coming in, it's going to heat up the east. So these are kind of the different temperature, kind of the regions in around the world that would probably have different solutions. Okay, but hereby I just trying to compare the tropical region and the arid region. So for building orientations, so south is usually in tropical is desirable because the direct solar radiation received by the south facade is easier to control compared to west and east. The daylight is relatively uniform. Okay, so for the north light is the best for daylighting because it's not direct and constant diffuse skylight. Okay, direct is something that we're trying to avoid, but we like diffuse lighting because it's giving comfort in terms of the visual to us, and it's also easier to control and it's soft. So it's good that usually as an architect, we will trying to place huge windows towards the north and the south orientations compared to the east and the west. So what we can trying to do at the east and the west facade. So we're trying to minimizing our windows over there. In the same time, probably we can say that we're trying to place some non-occupancy rooms, for example, non-habitable room, for example, our storeroom, for example, our toilet, for example, our services rooms over the west. That is good because those rooms basically we have to maintain it as a dry area. If we place those rooms at the west side, it means that it's most of the time it will be dry up, and it's like it will lessens the humidities of that room, so it will be good. In the same time, it can become one of the protection layer for the occupations room, like for example our study room and so forth. So usually when we're doing the site planning, we were trying to place our services room at the west. Okay, if we have our rooms at the west, so shading device should come. So we have to design a proper shading device in terms of the different orientation. So towards the east and the west, the sun is very low, the angles itself, so almost horizontal. So it's hard to control in this case. Okay. So as you can see the light distribution throughout the room here, if we're having the direct sunlight to the graph itself, distribution we're showing the from the high at the nearer to the window, and it was slowly going down towards the interior. But if the sunlight, indirect sunlight at the north windows at the noon, okay, it will basically giving quite consistent graph. The distributions of the daylight for the interiors. So that's why when we're trying to design, so it's critical for us to understand about the type of the room that we're trying to place at different orientation. So the other one will be assessing the obstruction using the vertical angle of the sky. So the depth and the height itself is very critical. See here the distance of the window to adjacent building. Okay, because not all the buildings is stand alone. That's why especially in the urban area. So for the height from the eye level to the top of the adjacent building, around 1.5 to around 2 meters. So from ground. So that is the point that we're starting to calculate on the hedge until the top of the building. So these tools are basically the ratios that we can trying to estimate when we're trying to design. If we want to have the ratios, which is D is 2 to 1, which is higher than that, the conventional window design is enough already for us to achieve the adequate daylight design. If you want to go lower, which is around 1:1, okay, like for example, the depth and the height itself is like same. So the large window and changes to room layout required. So it means that we have to rearrange back our furnitures and the window sizes and so forth. So if that is the ratio between the 1 to 2 to 1:1, very large window may find difficult to provide adequate daylighting. Okay, because that is too close together. That's why even you have a huge window, so it will be quite difficult for you to get impossible to depend on the daylighting. So we have to use artificial lighting, or we have to use some of the passive tools that can help us to reflect the outdoor daylighting into the interior, like light tube and so forth. Okay, so this kind of the ratio is can be one of our references when we're trying to design. That's why setback is very important in this case. We have to set our building off adjacent building. Like in Malaysia, and the local authorities requirements. Okay, so in this case, if we trying to let all of the buildings around having, our rooms in our building having an appropriate daylighting. So this is some of the ratios that we can trying to our design on. So for the daylighting strategies, when we come to the interior, the surface brightness is also important. As you can see, we have from the left, which is the task illuminance with low percentage. If we color our ceiling with dark color, like black color, so the task illuminance is usually very low, which is around 39%. Okay, but it depends. If you want to use, for example, your offices, the cafe with hipster style, because cafe is more artificial lighting that will illuminate make the interior nicer. So so probably you don't mind about that for the task illuminance, because reading is not the main event for the cafe. So usually you can paint the ceiling with dark color. It's okay. Okay, if you want to designing a classroom or offices, usually we were trying to go more than that. And I think that as you can see, that if we color our facade, okay, the wall itself, single wall with dark color, like usually the feature wall, it will increase a little bit more, okay, which is 50%. Okay, so but provided that you have to color your ceiling by using the light color or white color. If we have two feature walls, so it will also just because ceiling. So as you can see here, ceiling basically played a very important role in terms of the illuminance. Okay, recommendation you want to design for the interiors. Okay, the daylight strategies for the shading device will be one next one, which will be the harness reflected daylighting instead of direct sunlight. Okay, so just now we did mention about the interiors, right? The ceiling reflectance light of the ceiling is important. So in this case, if you want to trying to cut down the direct sunlight, but in the same time we want to increase the task illuminance, how should we do? Probably this one will be one of the recommendations that we can use, is using the shading devices that is at 1/3 of the windows itself. So one, it could cut down the direct sunlight. In the same time, it can giving the reflected daylight to the environment. So how to minimizing the solar heat gain? It will be rule number one, to avoid the direct sunlight. Number two, make use of the glazing technologies, external blinds, internal blinds to cut down the direct sunlight. So direct sunlight basically is the clues, is the cause that giving us heat itself. So this one will be one of the summaries of the classic daylight harvesting drawings that I quote from the quote 2018. Okay, so from here we can see is that the differences of the daylight factors accordingly and the locations of the layout that we can trying to use. Okay, that as our references when we're trying to design. Okay. So facade daylighting harvesting, as you can see here, if we designing a classroom itself, want to reduce the glare. Okay, we will trying to giving the internal blinds, and in the same times we can designing the ceilings that having the cut edges or the smooth surface that can giving us the reflected lighting. Okay, from the top. Okay, so the higher the window, the deeper the daylighting zone. So because everything is based on the diffuse light, reflected light from the ground to the ceiling and to our work plan, which is our tables itself. That's why the height of the ceiling is very important over here. So the clues, the rules of thumb that you usually use is like D. If let's say we have the depth or the height of our ceiling itself, that the functional depth that we can use is basically 1.5 to 2.0 D. Okay, it means twice of the height of the windows itself. Okay, so in with standard window and ceiling height is usually between 9 to 10 feet or 2.7 to 3 meter. So this one is usually why most of the room itself is around this height, because this height itself will basically give us the twice of the depth of the room, which is around 6 meters from the window. So usually we see that the height of the room itself is 3 meters, and the depth of the room is around 5 meters or maybe 4.5 or maybe 6 itself, which will be more efficient for a classroom or the offices spaces. Right, it's due to this the rules of thumb. Okay, so the other one will be the street windows provide more uniform daylight for us. Okay, so instead of placing the windows in one row window, I mean the easiest way for us to provide the adequate even daylighting with a nearly continuous is a street window. We have one row of the window provide and continuous and uniform kind of daylighting. If we have a punch window, it's acceptable, but it will create the contrast of light, and some of the area will be dark, some of the area will be light, bright. So this one is like the distribution is not that uniform. If we having the second photos, as you can see here. So okay. So this is one of the examples that you can see at the Bangi, which is MGTC Kuala Lumpur. So this is one of the green buildings in Malaysia. So they are using the light shelf and the shading device for the interior. So in daytime, they are totally no need to using the artificial lighting unless there's like raining, okay, or some we have the overcast sky, okay, and so forth. So that will cause some glaze, or maybe the light itself is not enough. So only they need to switch on the light. So these are the strategies with the window design. So just now, as a summary, we can say that the rooms itself probably we will it will giving us some of the recommendations in terms of the different height orientations, in terms of the light shelf, then what we need to use when we're trying to design a room with a good dusk illuminations. Okay. So some skylight design. Okay. Other than window itself, so the skylight design from the top sometimes is quite useful as well. Depends on buildings. For example, maybe we came across with the leisure building, or maybe we want to designing the areas at the lobby. So the skylight itself probably will give suitable light transmission features for us. Okay, so roof light, they are different. We have the skylight, sawtooth roof light, and we have the roof monitor. So these three Skylight is not suitable for the office space, but it's acceptable for the public space. Why? Because it will cause direct heat gain, direct sunlight, okay, from the glass itself, and it will giving heat to the indoor environment. For the sawtooth roof light, so it will give reflected or the diffuse light. So it's acceptable both for the office spaces and public spaces called the atrium. It's also giving the diffuse light only because it will it's suitable for both building because it won't give any direct sunlight. I mean the heat gain to us to the building. So for tropical climate, the sawtooth roof light and the roof monitor are considered suitable type of the features that we can try to apply in our building. So we can recommended daylight factors here. So for the atrium spaces is around 1% to 6%. So 1% daylight factor is equivalent to the brightness to an office spaces. And 6% DF daylight factor is 50% of the daytime hours. The lux level is above 2000 from then it's 0% of the hours. The lux level is above 2000. So for Malaysian standards MS 1525, the recommended one will be 1.0% to 3.5% daylight factor. So when we're trying to run a simulation itself, so the percentage of the daylight factor from the standards will be our benchmark or our references. If we get the result from the simulation that is around 1.0, 3.5, 4, which is considered the good or achievable task illuminate interior for our building itself. Okay. So for the low-rise atrium, the 2-story height building around 8 meter. So usually we're having the large roof is like 60 meter times 60 meter. 5% of skylight is equivalent to the 4% of daylight factor average. And 10% of skylight is more than the 10% of daylight average. Okay, so for the small room, this is a recommended one. Usually 5% will be of the skylight, of the total roof skylight will be giving us some clues, okay, of the atrium that we should design for the sizes of the roof itself. Okay, so for the medium rise, so this one will consider the same, more or less. 5% of the skylight is of the roof, total roof is considered 1%, which is suitable for our is suitable for our reading activities or things that we usually carry out. If we have a 20%, which is 3.5, if we having more than 20% of the skylight for the huge roof, the large roof itself, so it will be more, it's not suitable anymore because it will giving more heat, glare, discomfort to the occupants. If we're having a small roof, like 8 meter times 8 meter, 20% of the skylight, which is, it will give us lower than 1%, then it will be not suitable anymore because that factor basically will give us discomfort as well because it's like too dark, maybe not comfortable and so forth. So for the high-rise atrium, which is more than 10 stories, which is a 40 meter height, the large roof itself, 40% of the skylight is 1%, which is just nice for our daylight factor average. Okay, that's why as you can see here, from the low-rise, medium rise to the high rise itself, the percentage of the skylight itself will contribute to different daylight factor. So these are some of the rules of thumb that can guide us when we're trying to design. So for the clear stories, it's like a side-lit atrium, side-lit windows at the top. So this is usually above our eye level. The purpose is to admit the light, fresh air, or both. Usually it could be fixed window or could be top hung. Different on depends on different places. So for the clear stories, it's according to the different the building height. The recommended spacing for the clear stories and monitors is shown below. If we're having the height of like 1.5 height, so it's 2.5 hedge and will be, and a 4 hedge at the center will be the ratio, suitable ratio for us to having the appropriate clear stories. Okay, if we are trying to use the sawtooth light, so 2.5 hedge per sky or clear stories will be appropriate for us. Okay. So this next section will be the case study of one of the mosques at Malaysia. That this is one of the exercise by my students. So they are going to study one of the green buildings. So 3 and 4 of them form a group. So they study a green building, and they are going to study about the ventilation, about the daylighting features of that particular building. So in this case, I'll choose one of that, which is the Ara Damansara Mosque, okay, as one of the case study, okay. So this is the interior views of the mosque that they are fully utilizing the interior daylighting features, okay, reflected light, diffuse light, okay, shading devices, which and good ventilation, ventilations for the mosque itself. Okay, as you can see here. So the students have mentioning that, as you can see at the interiors of the mosque, they have some kind of like the atrium. There is the direct penetrations of the lighting. It's the skylight from the top, but the design is come with the horizontal shading device that eventually will give the reflected shading device lighting to the interior. So you can avoid the direct heat gain from the skylight itself. And in the same times, the height of the mosque itself is appropriate, and it's all being occupied, and it's all being applied with the shading device, okay, that can filter off the direct sunlight. So in the same time, it gives the natural ventilations of to the environment itself. Okay, and in terms of the big, but the interior itself is always being set in. So it will basically giving the modern look, but in the same time, it gives the tropical elements, tropical characteristics for the buildings, which to replace the pitch roof. Okay. So you see the corridor itself around the mosque itself is set as a setback, or the set as the overhang areas, which could avoid the direct heat gain for the buildings, interior building. At the same time, the double layer of the louvers, okay, with some of the carvings, okay, will give, one is aesthetic view, the other one is giving the different kind of, in terms of the ventilations, is give 2 layers that could promote the ventilations around. Okay. So according to MS 1525, the best orientation, sorry, okay, is it time up? Time's up? I guess.
Maybe 5 minutes more. Okay.
Okay. I try to be fast. All right.
Yeah,
okay. I think. Oh, sorry for that. Okay. So, in terms of this one, so you can see that the skylight, the natural lighting, so the features around the mosque is basically to promote the passive design. Okay, so these are some of the analysis that have done by the students, and these are the features that have been utilizing around the mosque and observed by the students. It could probably be useful when students trying to design for the public building. Okay, these are the studies that have done by the students by using Villas software. Villas software is a free software that you can try to download and try to play with, and can give you the result accordingly. Luminance, illuminance, and daylight factors. Okay, so passive design, these are the shadow casting and playings that have been run by students with using the SketchUp. So from here you can see is that what is the function software, and eventually this preset will giving you the results for you to compare. For table 1.8 daylight factor, like just now I have sharing that 1.0 to 3.5 is acceptable in terms of the lighting, in terms of the glare, in terms of the thermal comfort. Okay, so if student get this result, means that okay, your design is okay because it's recommended by the Malaysian standard. Okay, so in the same time, we can refer to other standards as well, which is appropriate to the locations. So the sky condition is one of the recommended. We have to understand at different country we have different sky type. Okay, like in Malaysia, usually intermediate will be one of the sky type that we're trying to preset in the simulation software. Okay, because this one will give the boundary conditions, the real life conditions of the environment when we're doing the studies. So these are the rules of thumbs that when we're trying to designing. Okay, for example, the layer factor is around 0.2 times the glazing area per floor area. For minimum, at least we having 0.1%, okay, of the glazing area per floor area. So this is in terms of the calculations when we're trying to design our floor plan. Okay, if we are not sure, probably we can draw in SketchUp. After that, we export to the VLUX, okay, and run a simulation. Then we will know, okay, how accurate and how much is that? Is it fulfilling the conditions or not? Okay, so other than that, okay, this one is one of the samples of my second year students project. Okay, so they just submitted their project by using their own building. Okay, so I asked them to do the simulation by using the VLUX for different 4 design days and 4 different times. Eventually, they analyze based on the simulation result. Okay, so this one is I just quickly go through. Okay, so I think after this all will be some of the case studies that I wish to show, and especially in terms of the design. Okay, like for example, this one. This one is the Institute of Moda Arab. Okay, at Arab, because it's a hot area, so that's why they require a small window. So the features that how they transfer the cultural or aesthetic features from the traditional building into the modern building. Okay, this is what you can see in comparable to 2, because the daylight conditions, daylight factors is very huge at their country. That's why they need to cut down in terms of the direct sunlight or the intensity of the lighting. That's why this kind of the features is important for them. Then for them to get the diffuse lighting. And for this petting farm or by the 70F architecture is a bifold dose. So if you want to have a place, for example, the areas that easier, like residential, easier for you to control the window itself. Probably this one, the bifold dose itself will be one of the interesting features that is easy for you to take control by manually. Okay, and in the same time, you can control provide the ventilations and control the direct sunlight into your house. The other sample will be the National Library of Singapore. So this by architect Keng Yang in Malaysia. So in tropical climate like Singapore, so if you want to design a modern building, shading device is very important. So in terms of this one, he has designed doing a great job by providing an appropriate kind of the shading device to the building itself. In the same time, you also can using the full glasses glazing to the environment, to the building as a building envelope. So the other one by Foster and Partners. So shading device and also can become the overhang, okay, and so forth. All right. So sorry. Okay. Yeah, okay. I think I almost done already. So these are some of the samples that, okay, sure. So I think you can have a look at the slide since we have shared it. So I think, okay, that's all from me. Thank you very much. Sorry for taking too much time. Also, it's making you in a hurry. Okay, thank you very much for that. All right.
It's okay. It's very interesting presentation. Okay.
All right, thank you.
Ini masih di view ya. Thank you for the presentation, Dr. PC. Now we will proceed to listen to the second presenters, which will be delivered by Dr. Amatal Rauf Abdullah. Let me share her short CV. Okay. Dr. Amatal Rauf Abdullah Al-Sharafi come from Yemen. She received her Doctor of Philosophy from University Technology Malaysia, Faculty of Built Environment and Surveying, Johor, Malaysia. Okay. She got some award on Pro Chancellor Award, Best Student Award of Master of Architecture, Academic Excellence Award, and she had achievement as the designer of a passive cooling architecture unit for building in the hot air region. And she has 5 international journal papers. She also has professional experience as freelance architect in Al Right for engineering consultancy under the supervision of Social Fund for Development Sana'a, Yemen, in Social Fund for Development cooperating with Veneto Italian Institution for Culture, in Association of Safeguarding of Historical City of Yemen, cooperating with International Heritage Center UNESCO. Please welcome Dr. Amatal Rauf, who will be presenting the second topic today on biomimetic for passive air conditioned architectural design for building in the hot arid region. Dr. Amatal Rauf, time is yours. Oh sebentar. Oh, masih unmute ya? Dr. Amatal Rauf, we cannot hear your voice yet.
Can you hear me now?
Oh, yes.
Oh, that's good.
We have a file.
My name is Amatal Rauf. I'm from Yemen. I'd like to thank first Dr. Wisno and Prof. Ismail, as well as UMS for inviting me to do this speech. This speech will be about, let me share the screen. This speech will be about biomimetics for passive air conditioning system in the hot arid region, in desert region. We'll start with the outline. We'll define biomimicry.
Excuse me, Dr. Amatal Rauf.
Yes, can you hear me?
Could you make a full screen, please?
Okay.
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 Okay, thank you.
You're welcome. So I'll start with defining biomimicry, the importance of the topic, and research methodology, result, and conclusion. Biomimicry is a science established in 1997 by Jenny and Pinos. It is a science of innovation inspired by nature. When we say innovation inspired by nature, we think directly about any innovation or discovery that we want to innovate to solve some problem, human problem. For example, to simplify the notion, the architect of this building is Sibling Theater in Singapore. He wants to design the building in glass, as we can see. But as we know, in Singapore, like Malaysia, like Indonesia, the temperature is very high, and as explained by Dr. PC, direct light is so intensive to the building, which will make the air in the building is very high. So the designer inspired the skin of the building from the Dorian trait, where the skin of the building they are movable based on the sunlight, adjustable. So by this way, the design make the daylight in to the building without making overheating as well, overlighting. This is the notion of biomimicry. So biomimicry is any innovation that can solve our problem as a human being without inspired from nature. So this study actually focused on hot arid region, as we can see, the one in dark red as well light. The temperature here in this area is above 35 to 50 degrees, as well as in Arizona, North Africa, our countries. So imagine that in Malaysia, we cannot stay in a room except if the air conditioning or the fan is working. What about this desert city? Actually, it's impossible to live without air conditioning. So living in an area with 50 degrees, the indoor will be overheated. Excuse me, I'd like to close the door. Oh, sorry, my son crying.
Okay, it's okay.
So, in an area with a very hot weather, the indoor will be overheating, where this overheating actually will cause a lot of problems, such as reduce our productivity. It will affect our decision, make us nervous. Sometimes it will make your health. For example, for me, if I stay in a room in Malaysia without fan or air condition, directly I have some asthma or some respiratory health. So this is an important issue to consider, cooling over design. So people around the world, they use air conditioning to solve this problem. However, there is a problem in desert city. They spend 70% of cooling loads of electricity for cooling loads. As we can know that 80% of the energy is consumed by burning fossil fuel, which is responsible for greenhouse gas emission, and which is the reason for many of ecological climate problems such as global warming and climate change, ozone layer depletion, ice melting, and recently tsunamis, and that's we face it in Indonesia. And as we can say, we, an architect, are responsible for this issue that happened to our Earth, because we design a building that is not studied, and such as using a lot of glasses, or paint the building with the dark colors like black or brown. By this way, the indoor will observe a lot of heat and it will be very hot, the indoor. So in order to solve this problem, we have at least to use, at least if you are, you have to use a low energy cooling system, or if we are a good architect and as well as responsible for our work, we have to design the building sustainably with passive cooling means, either by returning back to our vernacular architecture. If we can ask our grandfather how they stay in environment without using AC or fans, they have their techniques for designing the buildings. For example, my Prof. Ismail house, the building, actually the ceiling is separated from the walls with some, it's like a long vent, so there is no need for air conditioning system. Or we can design the building using passive cooling means, by searching in nature how do organisms cool their body or architecture. For my study, actually, I go to nature in order to inspire cooling design for desert region. If you want to design, for example, cooling unit from nature, inspired from nature, you just first go through some steps. First of all, define what is research problem. So my research problem here in this presentation is indoor overheating. We are searching for cooling device or processes. We have to go direct then to biologize the problem. How can I biologize the problem? You just ask yourself, how do organisms keep their body cool without facing overheating? To answer this question, you have to go to literature review and search. You will find many biological cooling strategies and many animals, they share some biological cooling strategies. For this study, I choose 3 biological, and I do comparative study for each strategy, 3 cases. Then by doing comparative study, you can extract the mutual working principle for cooling, and then you can emulate them into the design. For this design, you will do diagrams, sketches, computational simulation, and design study. I mean here by design study to do design specifications such as height, width, form, whether a circle or rectangular, direction, north, east, west, material and cost, position, applicability, whether this material is applicable in the region, and installation feasibility, how whether the builder can install it easily or not. We built a sample model for that, and we did experimental study for the design. We collect data, and then we did analytical study for this. And then we evaluate the design based in the cooling strategy, efficiency evaluation, and ecological evaluation. When we go to literature, we find some biological cooling strategies. We select only 3 that are evaporative cooling through nasal turbinate, radiative cooling through thermal radiator, and convective cooling through air conditioning. You'll ask me why you are studying right now the animals. Actually, we study the animals in order to found their cooling strategies and emulate or mimic them into a design. For the first case, that is radiative cooling through thermal radiator, the cases are jackrabbit ear, elephant pinna, toucan bill, and hornbill beak. As we can see here, I believe that everyone, when he goes to the zoo, he asks himself why the ear of this animal is very big in compared to his species category. I'll tell you that God created this part in order to lose the heat of his body. Like we sweat as a people in order to be cool. This animal, they use this appendage or organs to cool their body. As we can see here, the pinna of the elephant, the vessels, the blood vessels, this is translated into Indonesian, they are intensively instilled in the big pinna, and they are near enough to the surface, and they are formed like tree-like structure. All of this principle, they help us, or they help the elephant to lose the heat. Tree-like structure in nature is the principle of maximization. Let's imagine that this is the only part where the element lose his heat. He will not lose enough heat from this part. But when the element have this structure in his ear, as we can see, the red part is the area where the heat in the blood is dissipated and loose. So heat loss by this structure can be maximum. This is the working principle. I explained it before in the picture. The second cases is the termite mound, or the building of our architecture of the termite. The termite structure is like this. Actually, the scientists ask themselves, or they study this structure because this structure, although the temperature range from 3 to 50 throughout the year, the temperature inside is 31 throughout the year. That's why they studied. They find out when this temperature is stable because of special structure of the mound. As we can see, there is a channel here, there is chimney here, and every ridges here there is a channel. So when the sun hit the ridges, the air in the channel here heated, and there is will be different between the property of the air outside and air inside, and it will be diffusion, so the gas will be exchanged because there is pores in the surface. By this way, the clear air will come in and spoiled air will come out. The hot air by stake effect will goes up to the top of the mound and came back to the nest. By this way, the temperature of the mound keeps its temperature 31 degrees throughout the year. The most important, this architect has inspired his design from the termite mound, where he designed a chimney here and another channel. He created here microclimate space, covered the glass canopy, and some trees here, so the air inside here is cool. So the heated air in the rooms, it raised up from the room to the chimney out to the building. And because of the drawn here, air here, the air is drawn from the underground from here. The cold air comes from the underground to the room, and by this way, the architect achieved 90% of energy required for cooling. He saved it up. The most important cases here in our study is this study that is the evaporative cooling through nasal turbinate. This is the cross-section of the animals and nose, where the animal can cool the blood that is gone to the head or to the brain in this way. As we know, the brain blood must be in 37 to 38 only temperature. If it becomes very hot, it will be disorder. So in camel that lives in a very hot environment that reach up to 55 degree, God create for him this strategy to cool the brain. As God said, أَفَلَا يَنْظُرُونَ إِلَى الْإِبِلِ كَيْفَ خُلِقَتْ? Do they not look at camel, how they are created? Let me share here a video that explains how do camel call their body, brain. Excuse me, can you hear right now?
Yes, we can hear still.
Okay.
Camel have a huge moist surface area. As it breathes in, the moisture evaporates, cooling the blood vessels that cover the turbinates. This cool blood runs deep into the skull. Here it meets a vessel full of hot blood on its way up towards the brain.
I believe there is something going to be shared.
This
Okay. Maybe I can't open the video.
Yeah.
Okay. I'll explain it in this.
Again.
So when the camel inhale the hot dry air, the mucus in the turbinate evaporates, and by this way the blood in the turbinates became cold. Can you hear me?
Yes, but the slide is not showing.
Oh.
Oh yes, okay. Now it's good. Okay.
Can you see the drawing?
No. Yes. Now it's okay.
Okay. So when the camel inhale the hot dry air, the mucus evaporates, cooling by that the vessels in the turbinate. The blood became here cold. It runs down to the corneus sinus, where he meets the carotid blood that goes to the camel brain. By this way, the blood meets with the blood that go to the brain meets the cold blood here, and because of conduction, the heat transfer and the blood became cold before it reached to the camel brain. And by this way, the camel can cool the blood before it reaches its brain. So there is important things that we should consider to understand. There must be a wet surface to make this processes success, and there must be airflow. And if we can increase the contact surface area, the heat and water exchange will be more. The scroll form of the turbinate compresses a big surface area, and turbinate layers are featured by high conductivity. The design of the cooling, camel cooling, have been inspired into this design, where the turbinate had been inspired into clay plate. They take the same form, and they were covered by jute fiber, with jute fiber, and they were placed into a wind tower. This is the wind tower. Wind tower here is used in a desert country in order to capture the air from high level to the room. So when the hot air comes to the wind tower, it is drawn down to the cooling unit. The water evaporates and air became cool to the room. So we cool the air of the room by this way. Another cooling strategy has been used. So when evaporative cooling happened here, the water that is gone to this tank became cool. We use water pump to raise the water to this pipe to radiate the cooling of the water to the room. This is the design of the cooling design inspired by Kamil Mazal. It can be used for is in yellow, orange color. We did the sample of the design, and we go to Seoul in my country to do experiment. This is the sample of the design. This is the wind tower to capture the air, and it goes down to the design to become cool. This is drawn for it. And actually, I inspired the material from traditional cooling way in my country. They used to be used by a mission. They used jar covered by jute fiber, wet jute fiber, in order to make the water inside cool. So actually, I inspired the material from here. So the design of the clay covered by the jute fiber have cooled the air from here, that is 40 up down to 33 to this line. An example of that, in 12 a.m., the temperature dropped from 41 down to 22.5, and the humidity increased from 12 up to 76. The design have been examined in three materials, that is clay only, and clay covered by jute fiber, and clay with wood wool beds. The results show that the best cooling ability is for clay covered by jute fiber with 85%, and followed by clay with the wood wool beds, and then the last one is the clay only. However, all the cases here have shown better cooling ability than the numerical cooling bed. The cooling ability of the designs showed that the more the material can absorb the water and retain it in its context, the more its cooling ability. For example, clay, it absorbs only 90% of its mass, so the cooling ability only 66. Wood wool absorb 250% of his mass, so the cooling ability is 76. And jute fiber bed, they observe 444 of its mass, and that's why it reached up to 85% of cooling. We tested in different height, and we find that the more the design height, the more the cooling ability. As you can see here, the design height 1.6, so cooling ability reach up to 89, but the more than 1.6, it will not be significant to cool. There is no significant cooling, so we stop in 1.6. We examine also the design with only 5 beds and the same length with 10 beds, and we find that with 5 beds, the cooling ability is 69, and with 10 beds, the cooling ability is 76. So the more we increase the beds, the more we increase the cooling ability. Conclusion, we find that biomimicking or imitating the cooling strategy in nature can lead to an energy efficient as well as life-friendly architecture. Cooling efficiency increases by the increment of design height, wood wall beds, and dry air temperature bed porosity. Cooling efficiency decreases by the increment of wet bulb temperature, air humidity. Pressure drop increase by the increment of air velocity and wood wall bed. And best cooling efficiency is in lower air velocity. Thank you for your attention. Thank you for your attention. I finished my presentation.
Okay. Okay, thank you for the very interesting presentation, Dr. Amatal Rauf.
Thank you.
Okay. Before we discuss some question from participant, probably Professor Ismail Said would have a short discussion, observation about these two presenters.
All right. Can you hear me, everybody?
Yes.
All right. Thank you, Ibu Yayi, for inviting me to give a short comment on the speakers. Both of them are looking at things that make us more comfortable in our built environment. Dr. PC is looking at how to bring daylight into the buildings, right? And Dr. Amatal Rauf is how to cool ourselves when you are in a hot area environment, how to cool ourselves using passive method. Both are passive.
Saya pakai kepean ya.
So the denominator is passive. It is interesting that the amount of lux that we get from the sunlight is 100,000 lux, as much as 100,000 lux. I like to take that into another note. This is about astrophysics, which I learned it from my son. That in the sun, the light particles generated from the core of the sun, it is in the core, it's not in the outer surface of the sun. It is in the core. And in the core, the temperature is 15 million centigrade. 15 million centigrade. Meaning that electrons and photons are no more attracted to each other. It's a fission process. Yeah? In which that fission process also generates light particles. But in order for the lights to escape from the core of the sun, they have to go through the free radicals, which are the free electron and free protons. They block the particle of lights. In so much that it took 100,000 years, just now it's 100,000 lux, 100,000 years for the light to escape from the core of the sun. Meaning that the light you get now actually was in the sun of over 100,000 years. And it takes 8.3 minutes to reach us. So imagine things that is so, that we can relate. The only habitable planet on Earth is Earth. Habitable planet in the solar system is Earth. And yet, the sun, which already existed 4.3 billion years, keep on giving us the same light and keep on giving us the warmth in as much and the heat that happen like in a hot arid climate, for which that Dr. Amatal Rauf like to cool the building. It's in the passive way too. This is where science comes in. So I hope that everybody, especially students who are attending this Zoom lecture, will learn from this. Science are there, science already existed. We need to discover them. And then we need to innovate them into buildings, like what Dr. PC shows, like what Dr. Amatal Rauf did. Thank you.
Okay, ya bisa. Okay, before we end the discussion, I need to remind the participant, particularly who joined this talk on YouTube, to write down your details on the chat line for the proof of your attendance, especially for, it's okay. Especially for those who need a certificate. You need to write down your name, affiliation, and email, and we will send the certificate sooner after this. Okay. Okay. Maybe we can go to some question from participants. There are some question write down on the chat line to Dr. PC. Okay.
Yes, Ibu.
Yeah. The question was from
I
Ibu
think,
Nurrahmawati.
if not mistaken. Okay.
Okay. Ms. Nurrahmawati asks if we compare the shape of the atrium roof and clear stories, which one is more effective in providing light for the rooms? It has been answered by Dr. PC, but maybe you can elaborate it. Signal. Okay. Dr. PC, can you hear me?
Yeah. Sorry. Okay. I think basically I have already answered in the chat box for the two questions, right? Okay. The first one is from the VLux daylight visualizer. So I think that I have already shared in the chat box. Okay, basically, the software is free for both Mac and the Windows. Okay, so there's a lot of the YouTube tutorial as well. Can be learned by student as well from the YouTube. Okay, by using so you can refer to the links stuff. So for question number 2, basically in this question, I'm trying to highlight is like clear story is the positions or the type also of the windows that at different locations of the room. Basically, atrium is using the clear story. If you are trying to say that the atrium itself is a side lit means that it's like using the window is not from the roof, direct from the roof itself. Okay, so atrium is from the multiple clear stories that we are trying to utilizing at our roof. Just now I did mentioning there are we have three types, right? One is like direct from the roof. That is like skylight. The other two will be the sawtooth. The other one will be the side lit, which is the atrium itself. So clear story means that there's a window's positions that is higher than our eye level at the top itself. Okay, so regardless how the positions or the type of the room is, so maybe you said that if you are trying to address the location, like for example, the lobby, the big lobby, the exhibition hall itself. So we call that clear story at the top, the overall things as an atrium. Okay. If you said that just the window itself at the room, at the house itself, we call that as a clear stories. Okay. I hope that is clear. Okay. Am I answering the question?
Yes. Yes, it seems so.
Hello?
Okay, and there are also some questions from participants. Can we have the file of presentation to be shared to the participants?
The file of presentation, sure. I think I have shared the slide to Dr. Wisnu, if not mistaken.
Yeah.
Okay.
Permission.
Oh, sure. No problem. Yeah, no problem. Yeah, sure.
Thank you. Okay, thank you for the answer. We still have one question. It's a long question. Maybe Mas Wahid Yasin can speak over the microphone. Okay. The question is, I want to ask about the correlation between sustainable development.
Yes.
Oh yeah, okay.
Wait a second.
Okay, please.
I want to ask about the correlation between sustainable development, because the trend now, the sustainable development is to use material as woods and biopolymer and such and etc. So because we demand the sustainable design, we also take resource like wood from the nature resource. So how do we responsibility to take the resource of the nature? Because if we take too much of the resource like wood for sustainable development, we also have difficult to tackle the global warming or climate change problem. Thank you. Okay, that's it.
Thank you. This question is for Dr. PC or Dr. Amatal Rao?
I think I give the
For
question to
both.
Dr. PC.
Okay. Dr. PC, okay. Please,
Okay.
Dr. PC.
Thank you very much, sir. Basically, I think this is something quite subjective. How we going to address about this one? I think in this world, this is about the world of give and take. It's not about, okay, we use, then after that, that's it. Okay. Like some of the countries did mentionings about they're selling the carbons. I mean, the carbon footprint or the carbon index. Okay. So in this case, if we're trying to use the natural resources, what we should do is like maybe probably plan back. Okay, we have to contribute back to the nature to make it into the balance. The balancing of this world is what we call so-called the sustainability. So other than that, timber is one of the methods that the constructions solutions. But in the same time, we also have use in the construction world nowadays. One of the example is like we're using the glue lamp. Okay, like in Malaysia we have a Johor area, Tampoy area, we have a glue lamp showroom. Glue lamp is basically using some of the recycling woods or some of the wood pieces that is being laminated. Okay, laminated together. In eventually the strength of the glue lamp is much more stronger compared to the traditional wood. Okay, so it can become the structure, so it can become the furnishings, and it can become the roof and so forth. All right. So in this case, in terms of the natural resources wise, so it's like we trying to minimizing. One is balancing, the other is trying to minimizing the waste that we have contributed. So that's why we have a research. So how research can trying to reduce the impact of the constructions world nowadays is trying to utilizing the waste or reducing, at least we're trying to reducing the waste in the constructions to make the environmental better. So even in our green rating tools like GBI, or we have a green mark and so forth. So reducing the construction waste is one of the criteria that if you want to go for green building, that is a must for you to do as a designer, as a contractor, and anyone in the building construction industry. Okay, so I hope I did answering your question, because I think this is about the perspective that how as a responsible architect or responsible researchers that we should do to our environment to achieve the sustainability. Okay, thank you.
Okay, thank you, Dr. PC.
Thank you.
Okay. Is there still any questions? We still have about 8 minutes before closing the webinar. Or more, maybe for Professor Ismail, is still any observation? Okay.
There's one question for Dr. Amatal Rao. Can you refer to the questions in the chat?
Yeah. The presentation. Okay. She asked about some material to study. Actually, cooling to study cooling in architecture and technically and in mechanisms. It's very important to study cooling for building, because it's like high domain subject. If you can study cooling, it's okay. There is many, especially in biomimicry, there is many cases have not been studied yet. Some of them I show them like thermal radiator, as well as the termite mound. If you are interested in biology, you can go through them. The principles are already there, and you just come up with the design and examine it. For the books, there are many books about biomimicry. There is biomimicry in architecture. There is a specialized journal for inspiring designs from nature. If you are interested on them, you can just send me your email and I can send it to you, the titles. Here you go.
Okay, thank you, Dr. Amatal Rao. For Haryo, is it answer your question? Okay, I hope Dr. Amatal Rao has answered the question from Haryo Pamungkas. Okay, is there any observation again, Dr. Ismail?
Okay. No, I think we can end the talk today.
Session.
To all participants that's new to this program, this is the second talk that we have with University Muhammadiyah Surakarta. This is from Greenovation Research Group, which is situated at Faculty of Environment and Surveying, University Technology Malaysia, where PC is one of the docents at the faculty. And Dr. Mutarov is one of the PhD graduates under my supervision in the faculty, from this faculty. So therefore, those who feel that would like to further collaborations, you can contact Dr. Wisnu Setiawan. Then we can go further on this, because in my faculty, we have quite a big number of staff, academicians that can supervise or can assist you in your research. I hope that the relationship between UTM and UMS go furthermore, not only in the collaborations between undergraduate students and between our undergraduate students, but now perhaps go to the PhD students and master students. Thank you, Dr. Wisnu, for inviting us to join this talk. We hope that our collaboration go on and on. Thank you.
Okay, thank you, Amin.
Thank you.
Alhamdulillah, yeah, okay. Finally, we come to the end of the session. Shall we can start the photo session right now?
Yeah.
Could you please to open your video for a moment for all the participants? We will take the photo session. Sudah semua belum ya? Sam ya, oke. Oke, siap. Oke. Oke. Wait a minute ya, we still waiting for some participants. Hold on. Oke. Iya, mungkin yang lainnya enggak. Oke. Okay, some more participants. We still waiting for the video. Okay, yeah. Okay, let me count. Counting 1, 2, 3. Smile. Okay, thank you very much. Satu lagi, okay. Once more. 1, 2, smile. Okay, thank you very much. Again, we would like to thank you to all participants for your support. We hope to see you again on the next event, especially to both speaker, Dr. Leng Pao Chang and Dr. Amatal Rauf Abdullah. Thanks a lot for this inspirational knowledge sharing. We hope we could see each other offline very soon. Last, to Professor Ismail Said.
Yeah, thank you.
For the initiative to run this event. Inshallah, we will see you again soon on the next event. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Ibu. Thank you very much, Prof.
Thank you so much.
Thank you, Dr. Pal, PC.
Thank you.
Thank you.
Thank you.
Thank you, Dr. Amatal Rao. Thank you.
Thank you so much.
Yeah. Hopefully to see you again soon. Thank you.
Okay, see you.
Saya sebelum diakhiri.